Hi, welcome to this video. In today's video, I'm going to look at a very interesting problem. This is Mexican Olympiad of 2013. This problem is coming on the form of the composition, okay? If you take a look at this composition is a component of two functions. It's written on this form g of f of x, g of f of x. That's repeating 100 times, okay? So the question we are going to evaluate this value. G of f of 2013 100 times. That means the function g will appear 100 times and the function f will appear 100 times. I'm going to put these two functions into one function, okay, to make it more simple, okay? So now set p of x equal to g of f of x, okay? I'm going to evaluate this function, this composition. So I will have g, I'm going to replace f of x with its value. So I will have 1 over x. So I'm going to put this one into the function g, which is 1 minus 1 over x. So I will have a new function now as a p of x, okay? So I'm going to rephrase this one. So p of x equal 1 minus 1 over x, okay? This one I'm going to find this value. So the composition of this function 100 times of 2013, okay? This is what's required. Okay? Now we get a new function, okay? I'm going to compose this function with itself 100 times, okay? Let's start composing this function with itself several times to see you may have kind of patterns, okay? So let's compose this one 2 times. P of x is giving us p of, this is the original function. I'm going to replace this one into it, okay? 1 minus 1 over x is composing, this function is composed with itself, okay? So it's giving us 1 minus 1. I'm going to replace x by this one, okay? 1 minus 1 over x. By multiplying the numerator and denominator by x, we will have this one, 1 minus x over x minus 1, okay? So now my fraction becomes my fraction becomes x minus 1 minus x over x minus 1. I'm going to x, it will be cancelled out. So I will have with minus, I'm going to change this sign because I have minus in numerator. I have minus sign in numerator, and then I'm going to change denominator to the 1 minus x. 1 minus x, okay? So this is, I compose this function with itself 2 times. I'm going to compose this function 3 times with itself, okay? So that's mean p of x, okay? That's mean 3 times. If we take a look at here, this is composed 2 times. I have its value, okay? So that's mean 1 minus x, p of 1 over 1 minus x. I'm going to replace this one into, the original function. I will have 1 minus 1 over 1 minus x, okay? If you take a look at this second fraction, this is a reciprocal of 1 minus x, okay? Which is 1 minus x, okay? I'm going to cancel out number 1 because I have 1 minus 1. I will have minus multiplied by minus x, I will have x. Now I found a binary function, okay? So whatever you replace in x, it will be the same, okay? So now by composition this new function with itself 3 times, I found a binary function, okay? So that's mean I'm going to compose this one 3k times to see what's given us, okay? is 3 times. As you see here, this function is composed with itself 3 times, and then we found the identity function x. So whatever you replace in x, whatever you log in into x, it will be the same. It will be still the identity function. So in addition, I'm going to decompose this function 3k times to see what's given us. So p of x 3k times, okay, equal to p of x 3 times composed by another function 3 times, p of x 3 times, and so on, and all the way down. So this one is composed k times. Okay, if we keep doing this composition with every 3 times, you always get identity function. Okay, so I will have identity function, identity function, identity function, identity function. That's mean x. Okay, composition. If you compose 3 times and then you go into another composition 3 times, you will have identity function. Okay, so this means always k times. At the end, you get identity function. Okay, because as you compose 3 times, you found identity function. As you compose 3 times, you find an identity function. So there is a composition of k times of identity functions. You will have identity function. Okay, let's clean the board and bring this one at the top and continue with our problem. Okay, so now at the final step, so the question we are going to evaluate G of f100 f of 2013. So the question we are going to evaluate, so now I'm going to evaluate 100 times p of 100 times of x. Okay, that's mean p of 99 times, which is, I'm going to compose this one 99 times, which is p. So that's mean 99 times of x. Since this one, you get identity function, which is x, because we have every 3 times. Since we have this every 3 times is identity function, now to get 100, I'm going to replace k by 33. So 3 times 33, we have 99, which is this one. So the composition of whatever you have 3k, which is 99, we will have the identity function. So that's mean p of x, you get this one by replacing identity function into its value. Okay, so it has to be on this form 3k. So thus I'm going to evaluate this number. This composition is G of 100 of f of 2013, which is this one, p 2013, equal the same value, G of 100 of f 2013, which is this one, p of 2013, as we found here. So equal to 1 minus 1 2030. Okay, so this is the value of this composition. I have done with this problem. Thank you for watching. I will see you in next video. Bye. It has to be on this form 3k.